Hello, so it's Easter Saturday, which still makes me busy as a church organist. We're going to try and cram in this Realistic TRC1002, which is box 28. So we did 27 on its own a couple of radios back, so let's make sure you all know this is what we're doing. Box 28, set 1 of 2, Realistic TRC1002. That's where we are in the repairs, so still managing to get a few in. So this gentleman I used to work at Tandy's, and he sent in this, and he sent in the other set is a Realistic 1001. Now we've done 2 Realistic 1001s over the last 3 weeks, but we're going to do this other one. But I thought we'd do this first because I don't see many of these, not since we've launched these videos. I have done one, and I've done the field test as well, so we know they work for 6 miles, which I don't want you to confuse that. Oh, look, a fireman's using it, as if, yeah, right, the hunter might be. I don't want you to think for one moment that these are a toy, because they've actually got a 7-watt PA and the ERP is 1.5 watts. So instead of it being, when we looked at those German sets, the Kaiser and the DNTs, they were 2 watts, but in fact they're 500 milliwatts. But Tandy's have done exactly the opposite. They're actually 7-watt PAs delivering 1.5 watts ERP, which is quite something to achieve on a hand portal. It's got the range boost side panels, got a long telescopic, they work. Now the 2-channel, they come fitted with 1. So if you're going to have crystals made these days, they're going to cost you 35 quid each. So that's going to cost you 70 quid for 1 extra channel. So most of these never had any more channels fitted. I used to have crystals made at HiQ International back in the days when they were £7.50 each. It's all folded, and there you go. So we'll see what's in this. I've got the proper service manual here. It's a high quality service manual. I won't be able to do an on the air test. They don't have an extension aerial socket. Right, so we haven't got the dummy batteries in there, and we haven't got the instruction book. So it's a hefty set, on-off volume, squelch, channel A, channel B, and I say channel A comes as channel 20. You've got a battery test LED there, and hopefully a telescopic that's in one piece, otherwise the set is useless. Yeah, that's absolutely fine. So at the end of this video, I'll put it through to my base station like we would on the air tests. It certainly is far from new on the outside. It looks like it's been used on a building site with bits of concrete splash, and that's fair enough. We had some when I was at Nottingham Radio doing business radios. We did help people with CBs like we do here, there was a particular firm, and there were steeplejacks, so doing church tower and steeple repairs. It's in the name, but doing chimneys, industrial chimneys and that, a bit like Fred Dibner. And they dropped one of these off the scaffold once, and it did crack the printed circuit board in half. You know what, I put it back together and it went back into service. They didn't want to fork out for business radio licenses. Back then the business radio license was something like £140, so it's much cheaper for business radio. Light user one, very, very much cheaper, even for individual licenses like a small taxi firm, much, much cheaper than it used to be. And so are the radios. Anyway, these are £59.95 each. The cheapest I ever sold them cleared up was £39.99 each. And as I say, everybody will think, oh, 2 channels, it only comes fitted with 1. What a load of crap. But they're not. So we'll open it up. I can't connect it to the test gear. You've got charger and external power, so yes, I can power it, but I can't do anything else. We can't connect it for a cyanide reading, we can't connect it to the aerial, so all we can do is go through it when it's connected up to crocodile clip leads and run through it that way. So I do wish it had had an external socket, especially for antenna, but there you go. So carefully remove the back, and the crystals live inside here. This screwdriver is ridiculously far too big. I haven't switched the test gear on because I know that I've only got 10 minutes to start this video. So it's a single conversion superhet. It has indeed got one set of crystals. Disappointingly, you can only adjust one set to be spot on frequency. There should, you know, if this is thought out better, you would have 2 crystal trimmers. They probably never expected anyone to fit more channels. And although it would be in spec, with not trimming them individually at the time, you know, it can drift, especially now they're 40 years old. Look who cocked up in loading the paper into the printer. So the output device is the expensive Mitsubishi TRC1002 which makes the output device worth more than these radios these days. I was looking for the frequency chart. No, there isn't a frequency chart. Never mind. So we've got this split over 2 pages, and the way this is formatted, unfortunately, it's the opposite way around. So you've got a KIA 7313. That's an audio amplifier. You've got the MC3357 as the FM chip. So you've got 2 SC2166 and 2 SC2086 as the driver and the output, and a lot of the other stuff is done by the ubiquitous KTC 1815. And I have had problems with transmitter oscillation, not oscillating. So we've got these transistors in stock. I say we've had customers with quite a quantity of these sets very successfully, but they're big and they're chunky. Right, well, the first thing we have to do is to power it up. So we're going to need this lead that Mr. Chippy made. Or are we going to put crocodile clips onto the battery terminals? Okay folks, so we've got it connected up and we've got it on 12 volts. We've actually got it on 12.4. This is a 12 volt set and 12 volts is the maximum. I just can't be bothered to turn down the 0.4 bit. So we're going to put in, it's channel 20, so we're going to put in 27.7, well, we're going to expect 27.79125. So the first thing you do is we need to solder on to test point 1 and the ground terminal a lead, because there's no external aerial socket. That's what you've got to do. So we've got a lead which goes to a BNC, that goes into our test set through an N adapter. So far we're at test point 1 and ground. So we'll put the test set, we'll put the picture in picture on, make sure it actually comes up on the monitor. It still means nothing. Probably be a picture of Mickey Mouse when I come to edit the video. And we'll keep this in the low range, the 3 watt scale, because it's a 1.5 watt set. Well, we don't have anything happening on transmit. That's interesting. So we've got a dirty switch, because when I've gone backwards and forwards, they are self-cleaning, so it's only a matter of going backwards and forwards and it will, it should actually start working. I think we may have to intervene and spray this one. So as you can see, we have got 1 watt coming out of it. So there's 3 watts, there's 1. So it's only so it has the 1 channel, so all this is not applicable. So it's doing 1 watt at the moment. And at the moment, to do that 1 watt, it's drawing 344 milliamps. So we may as well go through the transmitter at this point. It's a long time since I've done one of these. It's probably, I mean, you can look at my back catalogue, it's probably 2014 when I did one last. So what are we doing? Transmitter. So they actually want you to connect an RF voltmeter to test point 6. And there's test points throughout this radio, so there's no taking the board out and faffing about soldering things in like you get with other sets. So test point 6 is just there. So we're going to have to use, this is going to be right fun. These are very time consuming, like a lot of hand portables. So we'll use our RF voltmeter, as they say. Now whether this will reach down that hole is another question, isn't it? So that is too deep for our probe. That is frustrating, folks. Now had they put a pin on this one, we'd be alright, but we're not alright because they haven't put a pin on it. Just see whether we can access it another way by looking at the circuit diagram. So test point 6, what's it connected to? We're looking for the transmit crystals. Oh, here we are. The test point 6 is there. So the junction of the 22k resistor 51 could also be a point which we could find beneficial if we could get to that. What about resistor 65? Nowhere near, is it? So we could have resistor 51, we could have resistor 50, we could have capacitor 62, and we can have the base of transistor 6. We may be able to get to the capacitor. I'll just move that to one side. I'm prodding the wrong one. Just verify once again, capacitor 61. No, it's capacitor 62 we need. So it's that one. Not getting anything in there, am I? That will just not go down low enough. We're going to have to improvise. So with Mr. Chippy's, this isn't ideal. This Mr. Chippy's crocodile clip lead onto the diode probe. We'll still get a peak reading, but it's pretty clumsy. If we were doing these day in, day out, I'd have to make or buy a suitable probe. Let's see whether that works. It does work. Let's go down, or upper scale in this case. So we've got that jolly good reading there. Right, we'll go back to the instructions. So it's L10. So adjust the core of L10 to obtain maximum oscillator output, then rotate the core by a quarter of a turn in the clockwise direction. So it's peak and then quarter back. How unbelievable is that? So L10 is the one there. So press transmit, get peak, and then carefully go quarter back. It's just starting to move down. I think that's what they're trying to get you to do. While we're at it, I just wonder what the frequency is that it's on currently. So we'll just switch to the next camera. (27.79060). So it's not quite out of spec, but it would sound off frequency. So next they want you to put it on frequency with CT2. And CT2 is there. That is a bit dirty. I'm going to waggle it round a bit. I'm struggling with this channel switch. Okay, 2779127. Fantastic. So next we're moving on for, we're going on to test point 7 now. So where's test point 7? It doesn't show. So there's test point 6. Test point 7 is down here. So it's the same situation. So we're going to be adjusting 11 and 12. So 11 and 12. Just hope that's on the screen enough for you to see. You know what? We're going to have to deal with this switch. We have to deal with this switch by removing it. I'm not chuffed about that because I've never come up against it before. I'll just check it's not the PTT switch playing up before we go down that avenue. No, it's just too intermittent to be able to align. So we'll pause the video and I'll have to take the board out. So I've got the board out enough to get some switch cleaner into the switch. So you've got a shield plate all down here, and you've got connection to the side panel, to the range boost side panels. So we'll just put some Service-All on that. It certainly doesn't look like it's falling apart. Have to take the rod antenna out. So we'll put these two screws back in the hope that that works. Power it back up. Right, let's hope that's a bit more reliable of it going into transmit. Right, so we've gone down that bit with some faff. So it's 13 and 16, they say, for maximum indication on a DC amp meter. Well, we're going to do it for maximum output, but looking at the ammeter as well. 13 and 16, so we're on there and there. I'm not now showing you the power meter, which I now need to be doing. So we're now less than 1 watt, we're worse than when we started, but it was tuned right. Okay, so now it's the power stage, so it's 19 and 21. Oh, the ammeter is with a technique, they're looking at current within the PA, so we're not doing that. Right, so we put that away. That's just really for aligning the early stages, but it's actually not, because this was oscillating, that was actually unnecessary. So we need to be able to adjust that one. So we're at 1.2 there. And then 21, not 20. just going to go through these again just to make sure we're at peak. Still at 1.2. Not that one. 1.4. I think we have to use a spectrum analyzer on these. So we'll just loosely couple that. So it says repeat steps 5 and 6 2 or 3 times, which is what we've done. And check the RF output within 1.3 to 1.7. So that's fine, we're absolutely on the ball there. And then 20 is our second harmonic trap, so it's 55.58. So frequency 55.58. Let's key this up. It's not showing us anything. That could be good. Or we need a longer crocodile clip to loosely couple it. I'll just put auto on this because we're not getting there. Auto. So there's our 20. Oh, I'm not showing you this. So there's our 27 meg signal, and we need to look at our 56 meg signal. And that's our 56 meg signal. So we need to now adjust L20 for that to be minimum. And that's about there. So I'm just going to trim, go back to this. So now we've adjusted that, I'm just going to make sure that we're just 1.35 watts now. So we'll just see whether we can just get back to 1.4. And we can. There we are, 1.4. So it's now 1.4 watts, and the current now is 411 milliamps. So for another, 60 milliamps, we've got another nearly half a watt. So a lot of faff, but we're there. Now we're going to check the deviation. Wow, it's bang on the money. 2.2 to 2.5. So just show you that once again. It's got a condenser mic in the bottom. Wow, absolutely perfect. Now the deviation on these is VR4. So I don't know how many VRs are in it. Not a lot. So deviation is the preset just there, VR4. But in this case, nothing was needed to be done. Well, that's the first thing I've not had to do. I don't think things like this normally get fiddled with. There, yep, that's absolutely fine. We've done the transmitter. So we want channel 20 on the signal generator. So I'll just dial that in, 27.79125. There we go. Now we've got to connect this to the test gear once again, so it's faffity faff time. And this time we go to test point 4 for our audio output. And wherever I can find my lead, they want you to start by making sure the thing's oscillating with your RF voltmeter connected to pin 2 of IC1. So we don't need to do that because it's oscillating, we can hear it. So they're going to have you set your frequency counter. We could do this. We would normally use the marker oscillator to do this. They want you to put your test probe. Yeah, the only BNC lead we've got on here is now on the soldered onto the thing. So we are going to use our marker oscillator as usual. It's a 455 IF. I'll tell you what, we'll do that right now. So we'll switch the tone off. We'll switch. Get that's not plugged in. So plug that in. So I want this on 455. System load. L is 2, isn't it? This one? Yeah, that's it. That's the one. .455. So we're going to be listening for that musical note when I actually get an output on this. I actually need more BNC leads. If I was doing these, which I'm not, we're only doing. It was a one-off, I promise you. We're going to have to put an adapter on. That's what we'll do. We'll put an adapter on there and a 4mm plug into there. We've now got ourselves a lead. Turn the volume up. So can we hear that musical note? We need to try and null that. And what are we nulling it with? Is it the capacitor? It is. CT1. Just make sure I'm bang on frequency. I am bang on frequency. That was really close. So we've got 455 kilohertz on this signal generator. We've got 27.79125 on the main signal generator. We've taken the tone off. I've got 10 microvolts going in, so it's not saturated, but I can hear a bit of a hiss. And then we'll introduce the output of the 455 signal generator into the IF, and then we nulled that musical note with the CT1 trimmer there. Nottingham Radio, we called the IF oscillator a woo-woo box, because that's what it does, doesn't it? Woo-woo, as you get it onto frequency. So we're now bang on frequency. I really should have taken, before I started, a sensitivity reading and I'll do that now. I mean, it was so marginally off frequency, it wasn't worth bothering, but I should have done this earlier. So for 12 dB, it is 2.3 microvolts. For 10 dB, it's 1.8 microvolts. And if it will do 20, it will. It is 5 microvolts. So, remember this is single conversion, not double conversion. Let's go through it and see if we get any improvement. Oh, squelch. Squelch at the moment, this isn't adjustable, so it's going to be, what we get is what we get. It's 4.8 microvolts tight. And the sensitivity end of it is 2 microvolts. Right, there we go. So now we'll go through all this. So we've put it on frequency. We're going to need to do the detector. They don't have you do this first. I think it looks to be L5. Let me just verify that with the circuit. There. So we'll do that first. I'm going to put a 100 microvolt signal on. So we'll now look at the oscilloscope. Maximum recovered audio. They have you do this last, but I don't think that's a good idea. So it's the one on its own up there. It was absolutely spot on as it was. Right, we'll go back to the cyanide meter. Drop the signal to around 4 dB. And let's go for this alignment. So it's L1, 2 and 3. So L1, 2 and 3, 1, 2 and 3. I wouldn't say that's made any difference whatsoever. That's it. I'm going to put a bigger signal on, just double check. Yep, that looks about right. So we'll now get a new reading for our cyanide. Hopefully we've made a tiny bit of difference. So for 12 dB, we've got 2.2. Wow. For 10 dB, we've got 1.6. And for 20 dB, we now have 4.5. Well, it has made a little difference. But as I bear in mind, I'd put it on frequency before we started, so that wasn't really fair. But I don't know what it's supposed to do. I don't think this hookup, with this bit of the lead being on screen, is ideal at all. But we know the sensitivity is as good as it's going to be. Let's see what it says it's supposed to be. Yeah, right. So for 20 dB, it's supposed to be 3 dB. And your limit is 6. Well, we've got it at 4.5, so we're well in there. And for 10 dB, it's supposed to be 1 with a limit of 2. It came in at 1.8 and we've got 1.6, so we're absolutely well in. Well, whether it's not made any difference to this, the squelch, now we'll find out. So, turn the signal generator to 0.3 of a microvolt, shut it off to standby, set threshold. Yep, that's threshold. Put the signal generator back on. So it's 1.2 microvolts, so that has improved. Let's put this on the attenuator so you can see where I am. So there's the 3 scale, and we're on the lower one, 1.2. And on maximum, it's 5, which is, yeah, it's about the same, isn't it? Good. It's a walkie-talkie at the end of the day, it's not a base station. So that's gone through everything. So that is meticulously tuned. So this early stage, which I was doing, really is when you're struggling with the oscillation. The test point's necessary for that first coil, but thereafter, if you've got an output, you may as well tune it for maximum. Remember, you're not tuning that unless you've got a spectrum analyzer, and otherwise you're going to end up on 56 megs. So the receiver, we've used the marker oscillator instead of going with a frequency counter and deducting the IF from pin 2 of the chip. We've used the second signal generator on 455. We've nullified it with the CT1 there. Well, that's the point. We never adjusted L4. Where does that come into play? Well, it's the RX oscillator, so it's oscillating, so we don't need to touch it. So if it wasn't oscillating, you'd adjust it. Good. We'll put it back together. Pause the video while I take the test things off. Right, so just before we put the final bits together, I've put the rod antenna in, it's all screwed together. I'm going to take the PTT out. I'm not sure that this PTT switch is also a bit like the channel switch and needs a bit of cleaner. So I've just taken that out, and with power off, we'll just wiggle that around a bit. I've got 3 of these sets brand new in boxes. Put that circlip back. There we go. Put the 2 halves together. So as a trade supplier, I don't normally look at battery contacts. I can see them down there and they look okay. We do not try customer sets on batteries. I actually used to rent these out in the 90s. They're just so reliable and rugged. Right, well, we're not going to hear anything, are we? I can't put it on the aerial, you know, so really it's a waste of space. We're not going to be doing an on-the-air test. We're not doing a field test. It's not our set. We've already done that anyway with our own. And we got 6 miles on it. Or we've had 14 miles on these. My late mother, I remember one day we'd got a power failure at home, and I said I'd call her when I was on my way through Grantham, which is the hospital is 6.6 miles. I always remember that. It's 6.6 miles from home, and I always used to call her on the CB when I got to the hospital, which was invariably a particular time. This is I was travelling back from Nottingham when I worked there. You know, I've talked about the 90s. And one day, I put a call out at the hospital, and she came back to me, and we've got some of these. We used to use channel 37. We use channel 31 these days, where possible. Obviously, we have to vary that from time to time, but there seemed to be a Russian taxi outfit on 37 when there was a bit of a lift on, so we've changed recently to 31, but yesterday we had to do 32, and obviously we're going to have to do 20 for this. And we've got a couple of these sets with channel 20 in on A, and I'd had crystals made by Haiku International. We'd got channel 37 on selection B. And so this one day I called through at exactly the normal time, and my mother was there, but somewhat lesser of a signal than usual, and I was still able to copy her, and she was on one of these, and she just knew these were so reliable and dependable. She just stood outside the house and was calling me on it, and that was 6.6 miles into a town, and you know, there you go. She didn't bring out one of the 3.5 watt ones or the 4 ones. She brought out one of these because she knew it was going to work. Now look, when I put this board back together, the red LED there hasn't gone through. I'm going to pause the video. I'm going to have to pop the thing back apart and just get that into place. Right, so what I'm going to do, I'm going to get Mr. Chippy to drive up the road, and we'll do a little test that way, just on its aerial. Oh, when we press the battery test, it actually lights up. We'll turn all the test gear off, so we've got as little interference as possible. I'll pull up the telescopic aerial. And we'll use the camcorders like we usually do.
So we'll just do this from the bench. I say it's not my set. If it was, we'd probably do another field test, but we did one before on these, and we do get the full 6 miles. So I've got it on the bench power supply. We're running that at 12 volts. There's probably going to be a hum on transmit because it's not going to have the filtering that some other sets are going to have. So we're switched on. The only sockets are power supply and charger. So I've pulled up the telescopic aerial till it's full. So all I'm asking Mr. Chippy to do is to drive a mile up the road and see if he can copy me from here. He's just going to drive down the lane, go to the petrol station at the end of the road, and that's all we can really do on this kind of set. So I'll make sure I'm on the range boost side panels. Tango 21 test.
Roger that, setting up still.
Roger. I'd love to walk around a supermarket with one of these. You know when you get these young girls about 17 on phones, I'd like to pull up the great big 1.5 metre telescopic and say, yes, yes, they've got eggs, yes, they've got butter, yes, that's right, just like these girls do, but on a blooming great big walkie-talkie.
Roger, right, I'll commence.
Roger.
Right, we're passing the house and recording.
Roger, got you going past the house, etc.
Roger. Tango 21 from Mr. Chippy, we now at the lay-by.
Roger, got you at the lay-by, over.
Yeah, where do you want me to record the, my radio, over?
Yes, can you do it? You may as well do it at this point, over.
Tango 21 from Mr. Chippy, now in Woody's lay-by.
Roger, so you're half a mile away. So I'm on the Realistic TRC1002. He's doing 1.5 watts. I'm inside a brick-built building, which is the internal walls are breeze block with a high metal content. So I know it's going to screen signals pretty much, which is why we can't do much more than this kind of test. So just the one power setting, this particular set doing 1.4 watts, over.
Yep, roger that, all received.
Okay, so we go over to the petrol station, we'll see what it's like from there, over.
Yeah, roger, will do.
Roger.
Right, we're coming up to the end of the lane.
Roger, got you at the end of the lane.
Yeah, it's already getting noisy.
Not surprised,
Roger. Tango 21 from Mr. Chippy, we're now in Ancaster service station 4 car. Tango 21 from Mr. Chippy, are you receiving?
I'm receiving. I don't know whether you copy me, over.
Yeah, roger, I'm just about copying you, over.
Excellent. Well, that's very good for considering what we're doing. So that's where the test ends, thank you.
Yep, roger that, 10-10.
Thank you.
Tango 21 receiving. Tango 21 receiving. I don't know whether you copy me, over.
Yeah, roger, I'm just about copying you, over.
Excellent. Well, that's very good for considering what we're doing. So that's where the test ends, thank you.
Yep, roger that, 10-10.
10-10, thank you. Okay, well that's exactly what I expected. He's 3/4 of a mile away, and it's getting about as much as you can do from inside a brick-built building like this. Right, we'll go through to our base station, and I'll put a link to our original field test, because I don't really want to field test a customer's set, and you can see how that went. Mind you, if I find that we didn't do a field test, I'll have to do one of my sets, won't I? And then we'll repeat it, but I won't be doing it with the customer's one. So we'll go to base station and we'll see what that sounds like, and of course it has to be on its built-in Electret microphone. Good audio output, they work well, and I can only do this crummy kind of test.
Tango 21 testing the Realistic TRC1002 into our Midland 76900 base station. Testing 1 2 3 4 5 5 4 3 2 1. As ever, thanks for watching. Hope you found that interesting.